types of sensors which are used for measurement of force. Basically, the device which is used for the measurement of force is called as load cell. Basically, load cell is consist of two elements. One is elastic element on which the force is exerted, and second one is some kind of secondary transducers. For example, if we have a diaphragm, then diaphragm acts as a elastic member, and if we attach strain gauges to that diaphragm, then whenever there is force acting on that diaphragm, there will be strain acting on that strain gauges. Whenever strain acts on strain gauges, there is change in resistance of a strain gauge. Then by measuring change in resistance, the force which is acting on that diaphragm can be determined. So here the elastic member acts as a primary sensor and your strain gauge acts as a secondary transducer. So the load cell is a device which is consists of some primary transducer and some secondary transducer. Usually some elastic member is considered as a primary transducer and other kind of arrangement is used as a secondary transducer. Now first type of load cell is a column type load cell. In column type load cell, what you have is you have a metal column or a rod. On this rod we have a strain gauges attached. Usually these strain gauges are connected in full bridge configuration. Full bridge configuration, and that is also Poisson's full bridge configuration. The meaning of it is, suppose epsilon 1 and epsilon 3 is the strain that is developed in strain gauge 1 and strain gauge 3, then the strain which is developed in strain gauge 2 and strain gauge 4 is minus mu times epsilon. That means minus Poisson's ratio times strain which is developed in epsilon 1 and epsilon 3. This type of configuration is called as Poisson's full bridge configuration. The advantage of using Poisson's full bridge configuration is the sensitivity of this strain gauge or sensitivity of this transducer is increased because of the Poisson's full bridge configuration. So the force which is to be measured is applied to this column type load cell. Whenever force is applied, there is strain developed in this rod. Whenever there is strain developed, there is change in resistance of this strain gauges. Then by measuring voltage of the strain gauges which are connected in Wheatstone bridge, you can determine the force. This voltage which is obtained across the Wheatstone bridge is given as 1 plus Poisson's ratio into gauge factor strain into input voltage divided by 2. Now suppose we know the force which is applied on the this column type device. Then how to determine that force? Suppose the force is given and modulus of elasticity is given. Then by determining this voltage, you can determine either strength, or suppose the force is given, then substitute the strain. Strain will be F upon A divided by E. So using this formula and modulus of elasticity, either you can determine the force acting on it or strain acting on it. So depending upon your requirement, you substitute which value to be measured in place of epsilon. If you are provided with output voltage and if questions demand determine the force acting on it, then simply measure the output voltage and substitute epsilon is equals to F upon AE. So that will give you the output voltage and force relationship. So this is how you can measure the force which is acting on this column type device. So this is the first type of load cell.